Hello guys, you are welcome back to this channel. This is Theory of Structures 1 revision lectures by Malam Amasani. Today we are going to look at shear legs and tripods. That's the first topic we treated in this semester. So I have one question for you guys, and this question is a standard national question from India, and I think we should look at it and see how to determine the member forces using tension coefficient method. Okay, so this is the question. It says the figure below shows two views of a tripod bracket. All connections are pin jointed. Find the forces in the three members due to a vertical load of 100 kilonewton acting at point O. Okay, so these are the two diagrams. We have plan and we have elevation view. Then we have member OA, member OB, member OC. And also in the elevation we have OA, OB and OC and 100 kilonewton at O. So this is the question. And remember, if you are dealing with tension coefficient method, the first thing is to always determine your tension coefficient. If you have your tension coefficient, then you can easily substitute in the tension formula and determine your tension. That's the forces. Okay, so these questions, directions are not given, which means you are to get your own directions. If directions are not given, then you are to compare the two diagrams and see which direction are you going to give for each direction. Okay, which sign convention are you going to take for each direction. So let's go back to the diagram. Let's go back to the question. Okay, so if you look at this from OA, OB and OC, from O to A is 2 meters, from O to C is 2.5 in the plan, then from O to B is 2 meters. Okay, if you look at the elevation, from O to A is 2 meters, from B to A is also, from B to O is also 2 meters, from O to C is also 2 meters. That's horizontally. Okay, so which means this is 2.5, this is 2, so they are not corresponding. Are you getting the logic? Okay, so if they are not corresponding, let's check the vertical direction. From O to A is 1.5, from O to B is 1.5, from O to C is 3 meters. Then in the elevation, from O to A is also 1.5, because alien dimension is given and this line is connecting the two, which is telling you that from here to here the distance is the same. Then from O to C is also 3 meters, so which means the dimensions are corresponding in the vertical direction. So when you are choosing your sign convention, make sure that what you give in the plan in the vertical direction is what you will give in the elevation as well in the vertical direction. Okay, that is why I gave y plus here. That's upward is positive y in the plan, upward is positive y in the elevation. They are the same. Okay, then the other two, which is z and x, you can give it to any of the two. Okay, so in my own case I assign z in the plan. That's from left to right is positive, from left to right x is positive in the elevation. So we are going to use these sign conventions to get our three equations, because we have three directions, x, y and z direction. So if you go back to the diagram again, since we know that we are starting with x projection and x is in the elevation, x is in the elevation. So going back to this, this is x, this is x, so this is the elevation, which means from O to A and O to B and O to C, they are x, they are in x direction. So if you look at this, from O to A is 2 meters, from O to B is also 2 meters, because A and B are at the same point. Then from O to C is also 2 meters, so they are all 2 meters. So what about the direction? From O to A to B to C is all from right to left. Okay, which is going against our sign convention, so they are going to be negative, all of them. So minus 2 TOA, minus 2 TOB and minus 2 TOC. That is what we have as equation 1, all of them equal to 0. The T is the tension coefficient, while the OA, OB, OC are the members. So let's go to y direction. In y direction, that's the vertically. So from O to A vertically is 1.5. We are looking at the plan now. From O to B vertically is 1.5 also. From O to C vertically is 3 meters. But this is going upward. That's A and B are in the upper side of the center of the point we are dealing with. That's point O. Okay, so from O to A and O to B are going to be positive 1.5, while from O to C is going to be 2.5. That is what we are having here. I mean 3. We have 1.5, 1.5, and then negative 3. Okay, then the 100 kilonewton is here. It is here. It is not shown in the plan, but definitely we can see it in the elevation, so you're going to consider it as well. So we have 100 kilonewton, and it is going downward, which means it is also against our sign convention, so it is going to be negative. That is why we have this as equation 2, all of them equal to 0. Then in z direction, which is in the plan, let's look at the plan again. In z direction, that's horizontally. From O to A and O to C are all against the sign convention, while from O to B is going in the same direction with our sign convention. So from O to B is positive 2 meters, while O to A and O to C are negative. This is going to be positive negative 2, and this is negative 2.5. That is what we have here, minus 2 TOA plus 2 TOB minus 2.5 TOC, all of them equal to 0. Okay, so once you have your 3 equations, then you can use any method of solving simultaneous equations to determine the unknowns, since we have 3 unknowns. So from equation 1, you are going to use your just think which one is going to make your calculations easy or simpler, or simple. Make it simple. Okay, so if you look at this 2 2 2, they are all the same. The coefficient are all 2 2 2. That is why I picked this, and dividing through by 2, I have the coefficient now as 1. Okay, so making TOA subject of the formula, after crossing the equality sign, it changes to positive, while the others remain as negative. Then I'm going to substitute this, which is now my equation 4. I'm going to substitute it into equation 2 and 3. Okay, if you look at equation 2, we have 1.5 TOA, 1.5 TOB, and minus 3 TOC minus 100. So this TOA, we are going to substitute minus TOB minus TOC as our TOA now. That is why we are having this. So if you multiply this, you have negative TOB. If you multiply this, you have negative TOC. So this is positive TOV, this is negative TOB, and they are all 1.5. So definitely plus minus, they are going to cancel each other. That's 1.5 minus 1.5 is going to be 0. Then we are left with TOC only. Minus 1.5 TOC minus 3 TOC is equal to 100. So if you add the two together, you have minus 4.5 TOC equal to 100. Dividing both sides by 4.5, which is the coefficient of the unknown, we have 100 divided by minus 4.5, which is equal to 22 minus 22.222. Therefore our TOC is minus 22.222. Okay, so we have this now. If we substitute the equation 4 in equation 3 again, this is our TOA. Then minus 2 TOA is going to be minus 2 into minus TOB minus 2OC in bracket plus TOB minus 2.5 2OC. Okay, so this is minus minus, it will be positive. This is minus minus, also it will be positive. So 2 plus this 2 will be 4, and this TOC minus this 2.5 is going to be 0.5, negative 0.5. Okay, so we have 4 minus 4 TOB minus 0.5 TOC. After crossing the equality sign, it changes to positive. So we already have TOC here. So what we are going to do is just to substitute this TOC here, 0.5 times minus 22.22 will give us, I think, that's 11.11. So dividing both sides by 4, which is coefficient of TOB, we have TOB as minus 2.78. That's our TOB. So we have our TOB now as minus 2.78. So which means we have two of the unknowns are now known. The TOC and TOB are known now. So we can easily go back to equation 4 and substitute our TOB and TOC there. So since we have TOC as TOB as 2.78 and it's negative, here we have negative also, negative, positive. Then 22.22 also negative, it changes to positive. Adding the 2, we have 25. So TOC is 25. Okay, TOC is 25. TOC is 25. So we have all these ones, we have these ones. I think now we have all the tension coefficients, so let's go and get our tension. Okay, so the formula for the tension is tension coefficients times length. And if you look at this, they are all, none of this is a vertical line, none of this is a normal line. They are all inclined. Okay, they are all inclined. So since they are inclined, definitely we need to calculate the length. Okay, so the simplest techniques I can give you is instead of trying to recall how to determine what do you call it, resolve or resultant of the length, I will just show you how to do this thing. Come back here, come here. If you come here in your X projection, wherever you have TOA in X and Y projection, look at this, we have TOA here. So you are going to pick these numbers here, 2, 1.5 and minus 2. Okay, you are going to pick these ones and put them in a square root to determine your LOA. So just square all the coefficients. We have 2, forget about the sign, just pick the 2 squared, 1.5 squared, 2 squared, add them together. That is what we have here, 2 squared, 1.5 squared, 2 squared. Then put everything in square root, take the square root of the sum. Okay, so after squaring this and taking the square root of the sum, I have the length to be 3.20 meters. The same thing for the second one. Let's go back because this one and this one are similar. So you see we have this, we have this 2, 1.5 and 2, which is similar to what we have here. Okay, so just substitute again and determine your 3.20 meters. Then the last one, which is the LOC, this is where we have OC. So this is 2, this is 3, this is 2.5. So substituting this here, we have 2 squared, 3 squared and 2.5 squared. Then square root of the sum, I have 4.39. So before you take the square root, if you are using calculator, you have two options. Maybe you can put everything in bracket. You put the square root first, then open bracket, 2 squared plus 1.5 squared plus 2 squared, close the bracket. Your answer will be correct. Or you can do it one by one, 2 squared plus 1.5 squared plus 2 squared. What you have as your answer, then you take the square root of the answer. Either way, you are good to go. Okay, so since we have the length now, we have the tension coefficient already, we can easily determine our tensile forces or the tension in the members. Okay, the tension in the members. So TOA, that's the capital TOA, is going to be small t times L, which is 25 times 3.2, and I have 80.00 kilonewton here, and it is positive, which means it is a tensile force. Then the TOB is minus 2.78 times 3.2, which is minus 8.89. So we have minus 8.89 kilonewton, which is a compressive force. Then the TOC is minus 22.22 times 4.39, which is minus 97.55 kilonewton. So we have a negative also, which is telling us this is a compressive force. Okay, the member is in compression. So that's that for this topic. That's this for this example. Okay, and this is the only thing I'm going to solve here, since we don't have time is already against us. So I'll stop here. In the next video I'll take another topic and solve one example, so that at least you can have 2 to 3 solutions to revise. Okay, so if you have any question, you can drop it in the comment section or in our WhatsApp group. Thank you.